Imagine a planet so massive it defies everything we know about how worlds are born. A gas giant the size of Jupiter, orbiting a tiny dim star. According to science, this shouldn't be possible, and yet it's real. Meet TOI-5205b, a forbidden planet that's leaving astronomers baffled. Today we'll explore how this cosmic oddball was discovered, why it shouldn't exist, and what it means for our understanding of the universe. In early 2023, NASA's Transiting Exoplanet Survey satellite, TESS, made an astonishing find: a Jupiter-sized planet orbiting an M-dwarf star called TOI 5205. This star is tiny, just 40% the mass of our Sun, and incredibly faint. Yet somehow it hosts a gas giant so large, it blocks out a whopping 7% of the star's light when it passes in front. To put that in perspective, if Jupiter passed in front of our Sun, it would only block about 1% of the light. But TOI 5205b is so big relative to its star that it creates one of the deepest planetary transits ever observed. The discovery was partly accidental. Researchers led by astronomer Shubham Kanodia were using the Apache Point Observatory in New Mexico when bad weather forced them to switch targets last minute. That lucky decision led them straight to this cosmic anomaly. Planets form in swirling disks of gas and dust around newborn stars. For gas giants like Jupiter, the process is thought to work like this. First, a rocky core forms over millions of years. Once it gets massive enough, it starts pulling in huge amounts of gas, growing into a giant planet. But M-dwarfs are the smallest and coolest stars in the universe. Their disks are much thinner and contain far less material. Worse, they don't last as long, meaning there shouldn't be enough time or resources to build a gas giant before the disk dissipates. That's why TOI-5205b is such a shock. A planet this big around a star this small? According to current theories, it's nearly impossible. Lead researcher Shubham Kanodia calls these planets forbidden because they shouldn't exist under our current models. And yet TOI 5205b isn't entirely alone. A handful of other oversized gas giants have been found around small stars. But this one is special. It's the first Jupiter-sized planet found around an M-dwarf this small. The odds of such a pairing are astronomically low. So how did it happen? Scientists have a few theories. Maybe the planet formed farther out and migrated inward. Or perhaps the disk collapsed directly into a planet, skipping the rocky core stage entirely. There's even a chance our understanding of protoplanetary disks is incomplete. Luckily, TOI 5205b is a perfect target for the James Webb Space Telescope. Because it blocks so much of its star's light, JWST could analyze its atmosphere in unprecedented detail, potentially revealing how it formed. M-dwarfs make up 70% of all stars in our galaxy. They're also incredibly long-lived. Some will shine for trillions of years. If they can host giant planets, could they also host Earth-like worlds? This discovery forces us to reconsider what's possible. Maybe planetary systems are more diverse than we ever imagined. And if gas giants can form around tiny stars, who's to say habitable planets can't? For now, TOI 5205b remains a cosmic mystery, a planet that shouldn't exist but does. And as we study it further, we may have to rewrite the textbooks on how planets are born.